Well, good morning, afternoon, or evening, and welcome to the lesson on adaptation and mitigation based on AR6. This is Professor Rios, and I hope you're doing well. The lesson has changed a bit from what it was before, simply because it's switched from AR5 to AR6 data. So this is an update to that presentation, and you should have the appropriate updated set of files, what you're looking at here, on Brightspace. So having said all that, let's get going. So climate change is what's referred to as a global commons problem, meaning it affects everybody. It's not restricted to borders. And the ideas of adaptation and mitigation can help. They don't solve everything, but they can help. And to be completely open, I'm a bigger fan of adaptation than I am mitigation, simply because adaptation can happen much more quickly. Mitigation is a very long-term issue that is tied to politics and all kinds of other things. So anyway, we'll get into that as well. So 1.5 degrees. So let's use this as a baseline. You will see this in an upcoming lesson as well. The lesson on environmental security. So 1.5 degrees Celsius is the baseline. 1.5 degrees is the global temperature beyond which many scientists feel that lasting damage will be hard to overcome. And by that I mean damage to the lifestyle that humans have basically become accustomed in present day Earth. Okay? Doesn't mean the Earth can't survive it. The Earth will be fine. Regardless of what the temperature is, it will simply adapt. But humans and the ecosystems that have been so finely tuned will have a difficult time adjusting. Remember this number, you should already know this number because it was in the first few lessons. Between 1880 and 2019, according to the IPCC, the global average temperature averaged over the oceans and land has gone up 1.09 degrees Celsius. That has since, remember this is through 2019, so if you think of 2020, 2021, and now 2022 and beyond, that number is likely to keep ticking up. Even if there are year-to-year dips, there will be an average. Remember the idea of a trend? The trend will still be to have this number increase. Again, closer to 1.11 already through 2021. So obviously this is as of the recording of this video, that is the latest information that is available based on Working Group 1, Summary for Policymakers, IPCC 2022. This is what basically the Working Group 2, so this would be where we get into the idea of adaptation, vulnerability, impacts. So this is the first part of the lesson, Working Group 2, impacts, adaptation, and the vulnerability. So the idea of the overall assessment by the working group is that, and I'll just simply read this, you can read it on your own obviously, but human interference with the climate system is occurring and basically it poses risks. And so their task is to assess impacts, how to adapt, how to assess risk related to climate, and how can that be managed through a variety of opportunities. So how can we as humans be resilient? How can we limit other issues or problems that adaptation can also bring along? Because adaptation is mostly good, but there are inherent issues with any of the strategies that you may adopt when you adapt. See the difference? ADOPT, when you adopt something. But then when you adapt with an A to something, that has its own built-in set of risks. So let's get into that. So here's the definition of adaptation. I'll give you a second to read it. It's not particularly complicated or long, but again, the process of adjustment to actual or expected climate and its effects. So if you live in an area that gets a certain amount of rainfall and the forecast is for that climate in that area to get drier, then you need to adapt your economy. You need to adapt how you build. You need to adapt everything about life in that particular area to basically live in a drier area or hotter or wetter or whatever the case might be. Okay? So human systems adaptation seeks to moderate or avoid harm and potentially exploit beneficial opportunities that adaptation may bring. Okay? So, and again, another much longer definition of adaptation here is in human systems, for example, adaptation can be anticipatory, meaning you can see it coming and you can sort of get ready for it. So one of those would be sea level rise. Sea level rise is not a big mystery. Sea level rise is happening. Sea level rise will continue to happen. So you can do things well ahead of time to get ready for it. Other things are more reactive, meaning, wow, you didn't see that coming, but it's definitely happening more and more. Therefore, you have to enact something to deal with it. Okay, so that's the difference between something that can be anticipatory or reactive. Okay, an adaptation, of course, is subject to what are called hard and soft limits. Those can be technology driven, right? We would love to do X, but we don't have the technology or the money or whatever the case might be to do it. So you may have to do something else in order to deal with that something, whatever that is. Defining adaptation, again, getting into more specifically, climate change is known to impact natural and therefore human systems. So the hydrological cycle, the shifting of geographic ranges of species like birds and migratory animals, agricultural yields and what can be grown and where it can be grown may be affected, okay? And not necessarily bad. Perhaps a warmer climate may mean a longer growing season in certain areas, so that's good. So again, more specifically, low-lying coastal regions, infrastructure threat due to extreme weather events. Think about Hurricane Sandy, Katrina, Harvey, Maria in Puerto Rico, okay? The increased mortality due to excessive heat episodes, food and water insecurity, marine and coastal ecosystems, terrestrial and inland ecosystems. How are any of these affected and how are they tied together? And this image here from AR6, it's a bit complicated in a way, but simple in others. So it talks about the idea of risk here in the middle. And you can think of it in terms of all these vulnerability, climate hazard, and exposure. So this would be the light blue, the yellow, and the dark blue. And where the three meet, where the climate hazard, the vulnerability, and the exposure all overlap, you have what's called risk. And so basically, you can think of it as all this sort of self-contained wheels, the impacts, ecosystems, including biodiversity, limits to adaptation, human society, and climate change. So these are the three things that had to be considered in order to sort of manage these three categories. And ideally, you want the white to be as small as possible, meaning your risk is as small as possible. You can't eliminate risk. That's true in everyday life, but you want to be able to minimize it. Okay? So if you minimize risk, what you do is you develop a climate resilient population. A population that can basically limit future climate change, where human populations, energy, industry, urban, rural, infrastructure, roads, buildings, dams, whatever the case might be, where you limit the risk based on a vulnerability and an exposure. If you limit these, you minimize this, and if you minimize the risk, you develop a more climate resilient society. That's in the end the goal. How easy that is to achieve, well, that's very debatable at this point still, even in 2022. So these are some of the adaptation strategies. And hopefully these become embedded in planning processes. And they can happen locally, they can happen regionally at the state level, they can happen at the national level. And in the United States, it is happening primarily at the state level. Every state is a little bit different based on their vulnerability, their exposure, and their known risk. Does that make sense? So let's go back to this. Most adaptation strategies are likely to still be very reactive as a function of what they're basically facing. So here's the idea of adaptation strategies based on region. So Europe is still the best of all regions, even though Europe has its own set of problems right now in terms of energy, but they are basically embedded. So the idea of embedding strategies in the planning process, Europe has done, frankly, the best of all the different regions. Here's how Africa breaks down, Asia, North America, including us, Central and South America. So risk can be thought of as short term, so basically now till about 2040, mid to long term, 2140 and beyond. And while this may seem like a long time away, when you think about the idea of the year 2040, that's when you all will be around 38 to 40 years old. So, not really that far away. And if you think about the year 2100, your kids, so if you're 21 years old right now and you decide to have a child in the year 2030, 2035, somewhere in there, your child will probably be around in the year 2100. He or she may be an old person by then, but they will be around facing whatever it is the world looks like at that time. So in the near term, and again, this is sort of I literally took this word for word from the AR6 summary for policymakers. I'll give you a chance to read, but I highlighted the confidence level of the IPCC for the near term. So, and I'll just read it. Global warming reaching 1.5 degrees in the near term would cause unavoidable increases in multiple climate hazards and present multiple risks to ecosystems and humans. And they say this with a very high level of confidence. The level of risk will depend on concurrent near-term trends in the vulnerability, exposure, level of socioeconomic development, and adaptation. They say this with high confidence. Near-term actions that limit global warming to close to 1.5 degrees Celsius would substantially reduce projected losses and damages related to climate change in human systems and ecosystems compared to higher warming levels, but but cannot eliminate them all. And they say this with very high confidence. So the key point here is at 1.5 degrees. We're at 1.1 right now. So we have a wiggle room of 0.4. That's it. If we let the planet, if the planet warms more than that, then we basically get away from this. And then it becomes much more difficult to deal with the risk that climate change poses. Does that make sense? So you just need to think of it as, where are we? Where is our fence? The fence would be 1.5 degrees Celsius. And what happens if we go beyond that fence? Sort of uncharted territory. In the mid to long-term range, beyond 2040, depending on the level of global warming, climate change will lead to numerous risks to natural and human systems. And they've identified 127 key risks assessed, mid and long-term impacts that are up to multiple times higher than currently observed. And so basically what this is saying is, if we keep this up beyond 2040, the impacts and the losses and the damages will be really, really difficult to deal with. Meaning, what we've become accustomed in what we called modern day society will be hard to deal with, because there are going to be more severe weather events, more droughts, floods, cold and warm outbreaks, storms that affect coastal regions. And that has an impact on the economy, that has an impact on infrastructure, that has an impact on all kinds of things. So that makes the idea of maintaining a functioning global society basically difficult to keep up. So here's the idea. So they're called RFCs, short for reasons for concern. And what this is saying is, and remember those SSPs? So the good one versus the really, really bad one, 8.5. What this is saying is, if we manage to stay in the 1.9 to 2.6, so that would be these two, then you know what? The risk impact will be either moderate to somewhere higher than a bit moderate. But if we get into the range of 4.5, 7, or 8.5 by the end of the century, even by mid-century, now we're talking about risk that is either high or very high. And what are those reasons for concern? Well, unique and threatened systems, extreme weather events like hurricanes, distribution of impacts across the Earth's space, large-scale singular events. So that could be a once-in-a-lifetime heat wave, for example, similar to what happened in Canada in 2021, where Western Canada reached temperatures of 120 degrees. We're talking Canada. That's unheard of, okay? So that's the idea here. So the shading goes from undetectable in the white, meaning no problems, moderate, high, and very high in terms of risk and impact. And again, these are all based on these projections, or the shared socioeconomic projections. So, future risk building resilience. So think about the idea of resilience. If you don't know what that word means, I probably should sort of pull back a bit. And, resilience is the ability to take a hit and bounce back. So if you're a resilient individual, if you go through issues in life that are problems, you're still able to bounce back and be okay. That's high resilience. If you're not, anything that brings you down can keep you down. That's low resilience. So you want to be a highly resilient society. And that's done through planning and thought and putting together an infrastructure that's able to deal with whatever the case might be. Hurricanes, heat waves, drought. Get it? So adaptation is place and context specific. So what might work in Africa may not work in the Southeast US, which may not work in Europe. So you have to know what works for where you are. Adaptation works best through complementary actions, meaning what happens in one place helps or affects what happens in a place nearby. So it could be simple things like planting trees. It could be simple things like building or improving the coastal mangroves, for example, in Florida or Louisiana, which these are natural systems of trees that live near the coast and grow near the coast, which can help prevent storm surge from making it too far inland. Get it? That's easy. That's a relatively simple and cheap adaptation strategy. And it has a complementary action, meaning that then prevents other things from being affected further upstream. So doing something in one area not only benefits that area, but benefits the area downstream from it. That is a complementary action. A solid first step to adapting is to reduce the vulnerability to present things that you know are happening. So for example, in Florida, where you have things like flooding during sunny days, because what's happening is as levels rise, the water basically finds its way through a very porous ground. So they tend to have what's called sunny day flooding. And so if you can actually address that by basically building roads up, making first floors, not really lived in floors, but floors where you do parking and other such things, you're basically reducing the risk of that population in a rather simple way. You can integrate local and indigenous knowledge of systems. It doesn't need to be fancy. It doesn't need to be high tech all the time in order to work. And one of the best examples of this would be the idea of planting trees. Planting trees can help basically grow forests back, which can help maintain moisture, which can help agriculture. So even if you're a drier area, by doing that, you're basically making the drought more manageable. You're maintaining soil moisture longer, which can help agriculture down the road. So that's the idea of building resilience. Future risk, building resilience, adaptation can be done poorly. So you can maladapt, which can lead to increased vulnerability and exposure. So you have to do basically planning ahead of time. If you overemphasize short-term outcomes, or you fail to anticipate what may happen as a consequence of your adaptation, that would be considered maladaptation. And if you do that, then it can lead to these increased vulnerabilities down the road. Here's a great little map. It shows you now, right? Or close to now. And these are the possible roads you can take. So these little lightning bolts represent climatic or non-climatic shocks like COVID, drought, floods. And here's your road, and you can take a road that starts off In the yellow, that's not great, but it's not bad. And then it gets better. Oh, good. And it gets bad again. And you sort of end up somewhere in here where your resilience is not bad, but it could be better, but it could be a lot worse. Or you can take these different paths where you basically ignore and avoid any kind of fixes, and you keep going down the red road, so to speak. And because the red road is already in the lower climate resilience level, something happens like a big drought or a big hurricane or something like a pandemic, and boom, you go even further down. And the world that you're left with at the end is something that is less resilient and much more difficult to fix. Okay? So here you're talking about the idea of, if you talk about the green, stewardship, knowledge, diversity, inclusion, equity and justice, and the whole idea of climate change, or ecosystem degradation, singular knowledge where it isn't spread, inequity, exclusion, and as a result, this leads to these kind of outcomes as opposed to the green side. In reality, I suspect that down the road, we will probably end up somewhere in the middle. That's just my opinion. We'll see where it happens. This little wheel up here, they're called Sustainable Development Goals. This is something that the UN has established to complete by the year 2030. And the Sustainable Development Goals include all kinds of things. We're not getting into that in this course, but notice how if you go the green route, all of them are met. But if you don't, all these sort of fall apart. That's what this is trying to signify. All the little banners from the wheel fall off. It's an interesting graphic. Hopefully it's visual enough to give you a sense of if you're taking the green route and a singular event happens like COVID, drought, or flood, you're still able to manage. You may go up and down for a while, but you're still managing. Make sense? All right, now let's look at mitigation. So the other side, working group 3. So mitigation is limiting warming, involves substantial technological, economic, and institutional challenges. So simply put, mitigation is a human intervention to reduce the sources or enhance the sinks of greenhouse gases. Mitigation is hard. I'm going to tell you this right now. I don't care what you hear in the news, mitigation is difficult because mitigation takes time. Mitigation is not something you can just click a switch, press a button, and it's done. Even if in 2023 you could press a magical button and the Earth was suddenly net zero for carbon, the carbon that's in the air since the 1700s is still doing a lot of work. Remember when we talked about the idea of residence time of carbon dioxide? Several hundred years. So that carbon is still out there doing damage. And because it's out there doing damage, it doesn't matter if we stop right now. Now, you want to stop, and you really want to go the route of sustainability. Solar, wind, geothermal. I would argue nuclear. So you want to basically get into a low carbon economy. The problem is the following. It is now expressing my opinion. So I'm letting you know that up front. You cannot run a first world economy on sustainable energy, period. You just cannot. We don't have the battery life. We don't have the storage capacity. The wind sometimes doesn't blow, the sun sometimes doesn't shine. Europe, bless their heart, has a lot of solar capacity built in. But guess what? Europe is really, really far north. So for a big chunk of the year, they don't have a lot of sunshine. So what are you supposed to do then? Wind? Okay, great. What if it doesn't blow? What if it doesn't blow and it's dark? Where does your energy come from? Get it? So unless you have the storage capacity, sustainable energy doesn't really work until you have that. So that process needs to happen slowly, or what you do is you introduce economic shock into the system, which unfortunately Europe may be facing in the winter of 2022, the winter of 2023. We'll see where that goes. And that gets into all kinds of geopolitics, the whole Russia-Ukraine mess, and the pipelines, and the fact that Europe isn't getting a lot of natural gas from Russia anymore, and all that stuff. So that gets into other aspects of politics. But again, think about it. You're used to a certain lifestyle in the United States. So is Europe. If you go the route of forcing only alternative sources of energy, that doesn't work in 2022 yet. It has to be blended in with other sources while you slowly ratchet down the use of fossil fuels. So what I'm trying to say in the long range is you cannot just shut off fossil fuels. You have to do it somewhat slowly, or you introduce economic shock into the system. The tough nut to crack. So quantifying mitigation, oh look there, it's complex, it's political, it's controversial. Sustainable development and equity provide a basis for assessing climate policies, and they highlight the need for addressing the risks of climate change. We've addressed that already. Effective mitigation will not be achieved if individual agents advance their own interests independently. There's another thing. In order for mitigation to happen, the big players, and I mean the United States, Europe, China, India, Japan, Brazil, those are the big players. If they don't play along, then mitigation doesn't really do much right away. It's hard to deal. It's hard to attempt it and expect anything to happen in the positive side. So this is where the complexity comes in. This is where the political aspect of it comes in. Adaptation, frankly, can happen regionally and locally. Mitigation, unfortunately, is a global issue, and it has to be addressed, frankly, globally. So it really does nothing for the United States if a state like California says, we're going to be carbon neutral by 2040. Okay, that's a great goal. But the fact that California is not fenced off from the rest of the world and the rest of the country. So if everybody else hasn't, then it really doesn't make that much of a difference. It has to be a globally addressed issue. So, complex, political, controversial. That's what I think of when I think of mitigation, unfortunately. So you get a sense of what's involved. So at the core of mitigating greenhouse gases, that's what GHG stands for. So the total net anthropogenic GHG emissions have continued to rise during the period of 2010 to 2019. Cumulative CO2 emissions since 1850. Average annual GHG emissions during that same time period were higher than in any previous decade. But the rate of growth did slow down. So, and that may be a function of efficiency. CO2 emissions from fossil fuel combustion and industrial processes contributed to about 78% of total greenhouse gas emissions from 1970 to 2010. Bottom line. So here is from AR6 Working Group 3, summary for policymakers. So it tells you what, so you look at the the legend. The light blue is CO2 from fossil fuels. Notice they make up the majority of it. The orange is CO2 from land use change, and forestry. So you'll see this term LULUCF. It's kind of dorky little term, but there you go. So CO2 from fossil fuel and industry, FFI, and CO2 from land use, so agriculture, land use changing agriculture to urban space, houses, and forestry, lumber. That makes up 11% as of 2019. Methane, 18%. Nitrous oxide, about 4%. And fluorinated gases, about 2%. So notice that in the end, from 1990, 40 gigatons roughly, or 38, and in 2019, 59. Notice how the increase from 2000 to 2010 was about 11, and the increase from 2010 to 2019 was about 6. So the percentage increase did go down, but it still went up, meaning compared to the previous decade. So is this good compared to that? Yeah, I guess, but it still went up. Again, there's what LULUCF stands for. And again, focus on what makes up the majority of greenhouse gas emissions. Here's another way of quantifying mitigation and emissions. So again, go back to 1990. When the Soviet Union broke up, there was a significant dip because their agricultural systems stopped or slowed down, but it picked up right up. The global financial crisis, so there was a dip, but then it went back up again. COVID, but then it went back up again. So this accounts for only CO2 from fossil fuel. So this bar that you see here, this line, is really only talking about this kind of greenhouse gas, the blue bar. Here's another way of looking at quantifying mitigation. So global net anthropogenic emissions have continued to rise across all major groups of greenhouse gases. So the blue bar, the orange bar, the red bar, the green bar, and the blue bar. So blue, orange, no, yellow, orange, blue, green correspond to these here. Blue, yellow, orange, blue and green. And here's another way of looking at it by era and by region. So notice who has contributed the most. Eastern Asia is now the more dominant contributor. It used to be North America, but it became Asia, mostly because of China, as of 2007. So Asia now contributes 27%, North America, Latin America, all the way to international shipping and aviation, which contributes about 2%. And again, that's taken into account all greenhouse gas emissions in this dark blue. So meaning the blue bar, the orange bar, the yellow bar, the green bar, that kind of stuff. Notice 38, 42, 53, 59. So it still corresponds to 32, 42, 53, 59. And then here's another way of looking at it from the perspective of the historic cumulative net anthropogenic CO2 emissions. So in other words, North America's primary contribution is the blue bar. Europe is mostly the blue bar with very little from the yellow. Eastern Asia all the way down to international shipping and aviation. Not surprising, international shipping and aviation, it's all fossil fuel. Get it? Fuel. Like to run the ships and the planes. And then this breaks it down as a function of net anthropogenic emissions per capita and for total population per region. So again, North America per capita is still the biggest contributor. Even though China now emits the most, but because they have more people, quite a bit more people than the US, per capita, we still emit the most in the United States per person. Even if China in total emits more now. So regardless, the bottom line to that whole little discussion is China has to get on board, India has to get on board. They account for basically almost 3 billion people, 2.8, something to that effect. That's basically close to a third of the planet's population. So they have to get on board. Brazil, the United States, and Europe. If those highly developed places get on board with curbing emissions in a way that doesn't destroy the economy or shock the economy, then improvements can happen down the line. So adaptation, bottom line, needs to come first. Mitigation, which is a long-term goal and process, will happen later, even if you enact them now. That's the bottom line of this whole discussion. Anyway, I'm going to leave it at that. It's a complicated topic. Again, in my opinion, adaptation first, and it's probably the most effective and easiest to enact. Mitigation, more complicated, political, controversial, and has to be sort of agreed to by all parties involved. And unfortunately, given the situation around the world these days, that's complicated because you have basically lots of struggles between the West and the East right now. So we're talking about, China, Russia, India, Turkey, and then you have the European Union and the United States on another side. So the idea of mitigation seems difficult at the moment. But we'll see. We'll see where this goes. If you have any questions, please let me know. Again, this is a upgrade to the previous version of this presentation and is one that is less based on hard data, and there's a lot of sort of people issues wrapped up in it. So if you have any questions, let me know. Otherwise, I hope you're doing well, and we'll talk to you soon. Bye.